there's a fellow, his name is Arvin, and he purports to do physics. He attempts to teach physics, and he's got a whole team of so-called physicists, and they're all, including Arvin, they're really mathematicians. They have nothing to do with physics. None of what they do has anything to do with physics. Physics has to do with rational explanations, and they don't have a single rational explanation for, the micro world, the world of what they call quantum mechanics, the invisible world of Mother Nature's. They do a lot of general relativity and, cosmic stuff as well. But primarily, here, as it relates to the discussion today, he's going to try to explain how magnets work. Does he explain it? Does he tell us what the mechanism? He asks the why question. Does he answer it? Well, the answer is no. He doesn't answer that question. And the main reason he doesn't answer it, he doesn't understand the difference between a description and an explanation. And almost no mathematician out there has any idea what the difference is. A lot of people think that an explanation is just a bunch of descriptions. It ain't so. Now, descriptions, what a robot might be able to do, just regurgitate, blah, 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 right? And that's different than thinking and figuring out, what the cause of something is, what the mechanism, the underlying mechanism, especially things like gravity and light and magnetism, okay? And so this is the issue. The issue is that these people don't understand the difference between a description and an explanation. That's where it starts. The other one is that, like all these mathematicians, they reify all concepts. They work with reified concepts. They're moving fields around. They're moving energy around. Force, time, they have all these concepts and they move them around. They bend time. I mean, what nonsense is that? And this is where the problem is. The language. Language has a lot to do with the fact that these people cannot explain a single phenomenon of nature. And we're going to look at magnetism today, and we'll find out how they answer that. But here, this is the fellow I'm talking about. His name is Arvin, and he says he's got a bunch of physicists, so-called physicists, working for him or working with him. And yeah, none of them are. They're all physicists. They're all mathematicians. And why are they mathematicians? Because of that. They work with energy, field, charge, wave function, virtual particle. What the hell is all that? Those are words of incantation. That's what they are. And he starts out on the wrong foot, as you'll see in a second here. I explained the quantum rabbit hole way. He's going to do a little Alice on us. He's going to do Alice in Wonderland stuff, which is all what mathematical physics is, what quantum mechanics is. It's just nonsense. It's the explanations are all nonsense. Okay, and what do they do? Their explanations are all irrational. Why? Because they explain using undefined math concepts. What they actually do, they reify the concepts, right? And then they move these concepts around. They think, hey, I explained it. Well, yeah, I mean, I can explain how the Earth moves around the sun with angels as well. Does that make it true? I can get the spirits to push the Earth. And that's probably more rational than what these people talk about, okay? And here, this is how good old Arvin starts his presentation. He starts out by telling us, he'll warn you up front. He'll say, I'm going to do rabbit hole stuff today. Alice in Wonderland. I mean, his words, okay? Listen to him. Here he goes, okay? Give me a second here. Let me put him on. Listen to him.
Why exactly do magnets attract each other?
But Arvin will explain it with
quantum field theory, or QFT, which is the best and most proven theory of reality that we have.
But be aware that
I'm going to go rabbit hole quantum on you.
So what's the issue? Well, there are several issues, as you will see. First of all, he's going to use, if they tell you what is the force that mediates the electromagnetic force, right? And it's these photons, right? That's the electromagnetic force. That's what they've always said. But now they say, no, it's mediated by virtual photons. Virtual photons? What are those? And so here, listen to him. He's going to tell you that they're going to use virtual photons to do their magic. And what are virtual photons? They're magical photons that pop in from the void as needed by the mathematician to do his explanation. Then they go back into being nothing. They exist and stop existing, right? Whatever that means, right? And they say, I explained it. So here it is. Listen to him. Here it is.
Magnetic forces result from the exchange of tiny particles called virtual photons. These virtual photons act as messengers, constantly exchanged between charged particles and magnetic poles, communicating the electromagnetic force.
I thought the electromagnetic force was done by real photons, but it turns out they're all magical photons. They're virtual photons which they can't measure, right? Because they're just fleeting. They come in and out of existence so quickly we can't put the probe on it. Okay? And yeah, I'm wondering how they're going to explain this stuff. And it turns out that they're going to invoke something even more irrational, which is Niels Bohr and Ernst Rutherford's planetary model of the atom. And of course, if you have an irrational atom to begin with, which is the one that creates the photons, the real photons, I guess, because then they create these virtual photons that come in out of nowhere. The magic, what did he say? The rabbit hole, the Alice in Wonderland photons. Okay, so they come in from the void, and it's all magic. Where's the explanation, a rational explanation for all this? I mean, he's going to tell you how magnets attract each other. And again, this is the only site on the planet that can explain physically, give you a physical interpretation of how a magnet attracts another. Here we can do that. These people, they talk about math and rabbit holes and whatever, right? And why? Because they start out with a planetary model. They've already started with an irrational photon, which is the virtual photon pops in from the void and ceases to exist instantly, right? And here's the magical atom that Niels Bohr and Ernst Rutherford created. Here it is, okay? Listen to them.
Atoms are composed of positively charged nucleus surrounded by negatively charged electrons. These electrons are tiny charged particles that orbit the nucleus, kind of like planets orbiting a star. Let's just visualize electrons orbiting the nucleus like planets around the sun. The animation you see here is a decent mathematical approximation.
It turns out that those famous orbitals, energy levels, whatever they want to call them, turns out that they are just mathematical concept. They're clouds of probability. Okay, so here's again, it's all from his site. Okay, I didn't invent any of this. You're hearing it from the horse's mouth. So listen to him. Here he goes.
At its most basic quantum level, magnetism comes down to electrons. Electrons exist in clouds of probability around the nucleus of atoms. The clouds represent the probability of finding the electron somewhere there if we were to measure its location. These clouds of probability are what we call an atom's orbitals, which describe possible locations for the electrons. And what we call shells are groups of orbitals containing electrons at the same energy level.
So what are they? Well, we're talking about an electron, which they've never seen. They don't know what an electron even looks like. They say it's a point particle. But this electron bead, we can call it a bead, a zero-dimensional bead, a point particle, occupies an energy level. Okay, what is that? Well, it's a cloud of probability that surrounds the nucleus. And one is negative, the other one's positive. Okay, whatever that means. I don't know what not positive and negative means except on my bank account. Then I know that, but as far as physics, I have no idea. Turns out that these electrons, which are point particles, right, have no size. That's according to the Wikipedia. They have no size, no volume, at least nothing that they can measure. So they say, apparently they're talking about a non-entity, but it turns out this zero-dimensional electron, right, spins. And you say, well, what is spin? You mean spin like a top? And they say, well, no, we use the word just to confuse people. So we say spin, but we don't mean spin. Okay, so here's a spin, this property that the electrons apparently have. Okay, here it is. Listen to him.
Electrons have a quantum property called spin. Spin is not easy to visualize because it is a quantum property. It's not exactly like a spinning top, but it is a type of intrinsic angular momentum that particles possess, even though they don't physically rotate. It's intrinsic, meaning it's a property that electrons have, similar to the way they have a negative charge.
Okay, so you don't know what spin is, but electron spin is just one of those properties electrons have. It's not like a top, but it is like a top because that's how they're going to use it. So on the one hand, they say spin is not spin, but we're going to treat it as spin for all our explanations. So we have our contradiction right there and then. We have no idea what spin is, but we're going to use it as if it were a top spinning. Okay, use it as a top, no problem. How do you explain attraction with a spinning top? That's what I want to know. I mean, you have two discrete tops, right? You can do this at home, always in the presence of a mechanic, right? You spin one top, you spin another top. Does one top attract the other one? Especially out there in outer space, like, there's no platform, no environment, no nothing, right? You spin one top, hopefully you can do that. You spin the other top. Will one top attract the other one? I mean, they're spinning, right? Isn't that the explanation? And so they're going to do it with these spinning electrons. And here it is. This is how he's going to do it.
Each spinning electron generates its own miniature magnetic field. The magnetic field lines represent the strength and direction of the force another magnetic material would feel in the vicinity of the magnet. Now, most materials have electrons spinning randomly in all sorts of directions, so their magnetic fields cancel each other out, resulting in no overall magnetism. But in certain materials like iron, cobalt, or nickel, something special happens. In these special materials, electrons tend to align their spins with each other due to quantum mechanical interactions. When electrons align their spins in this synchronized way, their tiny magnetic fields combine, becoming stronger and stronger. Large groups of aligned electrons create microscopic regions called magnetic domains, where all electron spins point in the same direction, creating a strong local magnetic field.
So he has this spin, right? He says it's not spin, but he treats it like spin. And he says that we've got these fields. What are fields? A bunch of numbers. He shows them as some kind of lines there. I don't know why he put the lines in there. How do you represent numbers with lines? What sense does that make? I mean, either we have lines, some threads, I guess, or you put numbers. Why don't they put numbers? Well, if they put numbers, you would not understand the physical interpretation. So, what do you mean? Numbers are vibrating and they interfere and yeah, because they're talking about numbers. But they put these lines and they say, see, these lines represent the field, right? The field lines, Faraday's field lines, which they say are not there really. They're just values in space. But all these values add up. And because these values add up, you have attraction or repulsion or whatever, depending on the spin of the electrons. Make sense? That's what they're proposing. And again, we come back to this word virtual. What is a virtual? He tries to explain what a virtual particle is. And again, it's rabbit hole stuff. Again, if you're interested in rabbit hole stuff, here you'll see it.
What the heck are virtual photons? It's going to sound weird if you haven't heard of virtual particles before. They're called virtual because they exist so briefly, popping in and out of existence as small quantum fluctuations of energy in the vacuum. All fundamental particles are excitations in quantum fields that are everywhere in space-time. Even in the vacuum of empty space, with no matter or radiation, it's teeming with virtual particle-antiparticle pairs being created and destroyed constantly.
So we have these virtual particles, again, that pop in from the void. We have spin, which ain't spin, right? And then there's another parameter. It's known as charge. And they use this word charge to make their case. And let's find out what charge is. Here's the scientific version, okay? Just for you, okay? Charge.
What is a charge? We don't know. We just know that it's a property that some particles possess.
Okay, so we have all these words that they use. They use spin, they use virtual particle, term, charge. They don't know what any of that is, but they're going to explain how a magnet attracts another. And so here's a summary so far. I hope you've been keeping track. He doesn't know what spin is. He doesn't know what a virtual particle is. He just says it's a magical one that pops in from the void, whatever that is. What's a particle? Is a particle a classical particle? I mean, are we talking about a little corpuscle or a grain of sand that pops in from the void? Or is it just another number for an equation? You know, what are we talking about? Then we have charge. Charge is easy. It's 1.6 times 10 to the minus 19 coulombs. He doesn't know that. He went to school. He doesn't know that. Something as simple as that. All his physicists, the ones that work with him, they don't know what charge is. Yeah, charge is a value. It's a number. That's all it is. Just another number. And they're doing physics. They're trying to give you a physical interpretation of how a magnet attracts another. And they're bringing all these mathematical concepts. They're going to do it that way. That's the mechanism they're going to propose, the physical interpretation. But it turns out that they cleaned their nose holes with all that anyways. This is the mechanism. Here, now we'll see the real super duper mechanism that good old Arvin and his team proposed. Here it is, okay? Listen carefully.
Imagine two people in boats tossing a ball back and forth. Each time the ball is thrown and caught, they push each other. Imagine these two same individuals throwing boomerangs to each other. Each time they do that, they move closer together. Virtual photons are like invisible balls and boomerangs exchanged between magnets, resulting in attraction or repulsion. This virtual photon exchange is something that all charged particles do. That's what a charged particle is.
So now you know what a charged particle is, what they didn't know what it was. Okay, but it turns out that, look at the mechanism. I want you to remember that mechanism. We have the ball between pushing. We all understand that. If I throw a ball at you, I push you away. Period. We're done. Okay? The boomerang, they want to do it also with particles. They say, look, we're going to send the particles on the outside and they push you in. So they produce pull, one person on the other, one boat on the other, through push. Why? Because in the last 10,000 years, not a single mathematician was able to explain the force of pull in Mother Nature's world, right? Gravity, magnetism, pull, right? And this is the issue. The issue is they never have been able to produce the force of pull in all of mathematical physics, in fact, in all of mathematics since day one. Why? Because in order to do pull, you need to have a physical mediator between the two things that are attracting each other. Look how simple that was. And the issue is they say, well, we can't see or touch anything. You know, like gravity, I can't see or touch anything here. Here we have two magnets, right? Right? And I can't see or touch anything between them. So they say there's nothing there. And yeah, the issue there is that an object is that which has shape, not that which you can see or touch. That was the whole issue. They needed to define the word object in the days of the Greeks already, and they never did. They never defined what an object is. They never used the correct definition. And so here we are, 2,500 years after the Greeks, right? And we don't have objects in mathematical physics. All we have are concepts. And so, yeah, they cannot explain the force of pull, the force of attraction. But that's what he's going to explain here. And how does he do it? He does it with the force of pull. He does it with the boomerang mechanism. I throw the boomerang, he goes behind you and pushes you towards me. It turns out that he says that, but that's not what he's going to use. Here it is. Listen, here's repulsion first. Let's do repulsion first, then we'll do attraction. Attraction is the one you got to keep, in mind. That's the one you want to pay attention to. Okay, here's repulsion, okay?
When two similar poles approach, north to north, south to south, their electron spins are aligned in opposite ways relative to each other. One magnet has electron spins oriented up and the other magnet oriented down relative to it. In quantum mechanical terms, this arrangement creates interference patterns in their electron wave functions, making it energetically unfavorable for electrons to occupy overlapping states. This raises the energy, making the system want to avoid that state, causing them to push away. The electron wave functions from one magnet interferes negatively with those of the other magnet. A higher energy state is created in the space between the two similar poles. The materials want to avoid that space and move to a lower energy space, which is away from each other. It's like pushing the two magnets up a hill, which has higher potential energy, as shown in this animation. The lower potential energy is away from each other.
It's all math, what they're talking about. But that's really irrelevant. The issue here that I want you to focus on is that they looked at the region between the two magnets. They say, look, all these superimpose, okay, and they create some effect that forces them to push each other away. Great. How do they do attraction? I mean, remember attraction, what it was from the outside inwards. You push from the outside, push the two things closer together. That's not what he's going to explain. Again, he's going to go between the two magnets, tell you something about some math going on in there between them, and he says, I've explained it. I explained attraction. Listen, this is the big one, the attraction. Here goes.
When opposite poles approach each other, electron spins from one magnet align nicely with spins in the other magnet. Their electron wave functions overlap constructively, lowering their combined quantum energy. A lower energy, more stable state is formed in the space between the poles. So the magnets spontaneously move to that space. That is, they move closer together. It's like the two magnets going down a hill to the bottom, which has lower potential energy, closer to each other.
Well, did you see any boomerangs pushing from the outside? Now, again, he talks about the interface, the region in between. So one thing doesn't match the other. One thing has nothing to do with the other. They talk about this boomerang and say, oh, I understand a boomerang, pushing from the outside. That's not what he explains. He wants to explain attraction from the inside, saying there's some math going on inside there, and that, you have higher energy, lower energy, wave functions, charges, whatever nonsense, positive, negative, and that's what pulls them together. And again, it's interesting that, good old Richard Feynman, he wasn't able to explain magnets either, but he thinks he's smarter than Richard Feynman. He can, because he does it with virtual photons or wave functions or who knows what else. So what do we call all these mathematicians? Well, we call them idiots. Idiots. That's the correct word. So what's an idiot? Let's define that as well. We need to define all our terms in science, okay? An idiot. So a word comes from the Klingons, okay? Idiot is a person with big ideas. See, rational people have ideas, normal ideas, but mathematicians have big ideas, idiots, okay? And so we call them idiots, or for short, idiots, okay? And that's what they are. We have a bunch of idiots in the mathematical establishment, and they claim that they can explain how magnets attract each other when they do no such thing. It's false advertising. And, a lot of people go there and listen to them. They have a lot of subscribers, a few more than I do. But this is what they learn. They learn nonsense. They walk away and say, oh, I got my shot of science for the week. I can now explain magnets. How do you explain them? Well, it's the boomerang, pushes you from the outside. That's how a magnet attracts another. Okay, so if people are content with that, that's fine. They have a false sense of security. So how do we explain it in science? How do we explain attraction between two magnets in science? Okay. Well, we start with a scientific method. The first thing we have to do is get rid of the mathematical method invented by the people in the 17th century. We get rid of all of it completely. None of it belongs to science. None of it is science. None of it has to do with physics. We don't observe. We don't predict. We don't do experiments. We don't describe. We don't invent technology and call it science, and that we prove science through technology. We don't do any of that. Okay? So hold it. What do you mean? None of that? Right. Science is rational explanations. Let me repeat that. Rational explanations. That's all that science is. You need to explain how our universe works. And once we do that, we're done with physics, we're done with science. Okay? And here's the scientific method, which is the way you present your explanation to a juror so that they will understand, not so that you will convince them. We don't talk about knowledge, we don't talk about proof, about fact. We just talk about, the objects that we're going to use. We show them a mechanism, we show them the causes. That's why we can explain how a magnet attracts another here, okay? And the first thing you need to present are the objects. But the next thing, you see definitions there. The first thing, which is the second thing, right, is what we call the foundations of physics. You need to define these words whether you like it or not. Otherwise, you cannot do physics. Otherwise, you cannot explain mechanistically the causes behind a phenomenon. So you need to define these words. Object, space, distance, location, exist, motion, and concept. You need to know the difference, especially between a concept and an object. These people don't understand the difference. They use all these concepts as physical objects, move them around. You can't do that in physics. You're cheating. It's false advertising again. Okay, so that's where we start. Okay, we got to get our house in order before we start. And what we present is a physical object, an object, not a concept, okay? Instead of this wavy thingy that these people present, we present a rope. Okay, we're saying that the mediator of light is not a wave, which is not a thing. Wave, you see those arrows there, those are vectors, which are numbers, and they make up these fields, which are not things either. They're concepts, again, field, bunch of numbers in space. And so what these people have is a mathematical concept, and they represent it with these arrows and these curved lines. None of that has anything to do with physics. Okay, physics, you need a physical object. We're saying the object that they've always confused it with is a rope. Only a rope can tell you certain things that, they should have figured this out a long time ago, but for some reason it never came up to them. One of the things that it can explain is this, the fact that, a rope, back here you can see it, right? The more links you have, the more frequency, the shorter each link, and vice versa. Okay? The longer the links, the fewer links you have for a given length of rope. And that's what that little equation is. The speed of light equals frequency times wavelength. They're inversely proportional. The only entity imaginable that can represent that is a DNA-like rope. It's got to be a rope. Okay, it's got to be a physical object. Rope is a physical object. Wave is not an object, and neither is a mathematical concept such as a quantum particle or, whatever they want to call it, or wave packet, or all these words that they've invented. None of those are physical objects. None of them qualify as physical objects for the purposes of physics. They cannot be used to simulate physical interpretations, mechanisms. Okay, so here's we put them in motion. Here's let me make this a little bigger. Here you have them in motion. Again, they move this wave, which is kind of scary because what you're staring at there, the wave going in one direction, those are vectors that are moving, and fields, which are a bunch of numbers. So they represent them with these lines and arrows, and then they move them. And so they give you the impression that they know what they're talking about. No, we have a rope, and the rope does not move forward or backward. It torques in situ. By torquing, we can explain why light is so fast, again, because, torsion is the fastest thing known to man. You cannot imagine anything faster than a torsion, and the reason is that it's already at the other end. The rope is connected already at the other end, so it doesn't have to go anywhere. It's the torsion that you can say propagates along the rope. Okay, that's what it is. Okay, so we have a different solution to the problem of physics. Okay, how about the atom? Well, we talked about the atom a little earlier, and here it is. Here's the quantum atom. Little bead just standing next to a bowling ball with a little golf ball going around. And they draw those circles because they want you to understand that those lines, those circles, they're the itinerary. So, because otherwise they would have to draw, they would just draw two balls, one ball next to the other. So they draw the lines so it gives you an idea that there's motion built into that photograph. Okay? And what do we replace this nonsense with? Well, we put something else, and it's this. It's the the rope atom, the rope model of the atom. One thread coming from every rope in the universe goes to the center, forms the electron, the proton star, and then the other one curves around and builds, the red one there, builds what we call the electron shell or membrane. It's a membrane that encapsulates a star. That is the atom that good old Rutherford says is primarily empty. What was empty was his head. That's what it was. He had no clue whatsoever. He didn't realize that touch is not a property that Mother Nature has from the start. It's an emergent property. Okay, we can call it like that. Okay, so we're not going to deal with touch now, but essentially an object is not that which you can see or touch. It's an object is that which has shape. And these people say, let's go to the lab. Oh, why are you going to the lab? I want to see and touch what? Gravity? The mediator of gravity, the mediator of light, the mediator of magnetism. You want to see and touch them? They're invisible, intangible. We're not going to prove it, confirm it, verify it by going to the lab. This is a conceptual issue only. That's the only way you will understand it. You got to sit back, do some what they call armchair physics, and visualize. Try to imagine what Mother Nature could be using to do her daily work. Okay, so here's the difference between what quantum proposes and what we propose. There you have the quantum atom doing its quantum jump, and what comes out of there is these numbers that they illustrate with arrows and lines and whatever. And no, we have a physical mechanism. We have the atoms are pumping, they're expanding and contracting. By doing so, they torque the rope, which is what the atom is made of. Okay, so it's all, there's a single thread in the entire universe. That's all there is. And that turns into every atom and the ropes that interconnect them. Okay? And yeah, I won't go into a detail on that. I've done that in other videos. Let's move on here because we want to look at magnetism. Before we get there, we have to look at electricity. What is electricity? Well, electricity under the rope model is, again, you have these atoms that are pumping, doing their quantum jump. And when you merge these atoms, you know, they can blend. The rope essentially blends into, you know, one atom blends into the other, and the rope that's between them kind of disappears. Right? Because it doesn't disappear like, you know, vanishes. What it does is one moves into the other and forms this figure eight, like when you have two hydrogen atoms, you can get an H2 molecule. Why? Because one kind of screws into the other. But anyways, here we show a bunch of merged cells. We illustrate them as atoms here, you know, just a single atom, hydrogen atoms, if you will. But you got to think of them as, you know, atoms that are merged with other atoms forming molecules, okay? Because that's what's going to really rotate. So let me show this here, which is electricity, essentially, you know, and keep in mind that, you know, it's swinging around the threads. Why? Because the threads there that you see swinging around, that's going to be the magnetic field, which is 90 degrees to the direction of electricity, which is towards the sides. Okay, so here, let's look at this. You've got the quantum model, which is, you know, all these electron beads moving from negative to positive, whatever that is. You know why? We don't know, but they just, negative likes positive for some reason. We don't know what that means physically. And we're saying, no, what we have here is clockwise and counterclockwise. If you take a snake, a worm, and from my end, I turn it clockwise, right? From your end, it had better be going counterclockwise. And that's what you see at the bottom there. From one end to the other, you know, so-called negative and positive, that's clockwise and counterclockwise. Mother Nature understands clockwise and counterclockwise. Mother Nature has no idea what you mean by positive and negative, okay? So, but keep in mind, as the electron shells spin, right? They're spinning in situ. They're forming this torque all around. What they're doing is swinging threads around themselves because of the speed in which they spin, okay? And so here we have two gentlemen, Axel and Rod, okay? And this is going to explain to you the mechanism of attraction and repulsion. Again, we're presenting a physical model of magnetism. Okay, of attraction and repulsion. That's what we're going to do here, okay? We're not asking you to believe. We're asking you to understand. People sometimes confuse those. Say, Bill, you believe in... No, it's not an issue of belief. It's a question, do you understand what we're proposing? And there you see one rope, and by the way, people confuse rope with thread. We represent it with a rope. What swings in this theory is are the threads, okay? And keep that in mind. There's a big difference between thread and rope. Thread, there's two threads in one rope, okay? What's going to swing around are the threads. But here we're representing it with a rope, and that might confuse some people. But we're just looking at the mechanism here. When Axel, the blue guy, right, his rope comes up, rods comes down, okay? And so they kind of, you know, latch onto each other and pull. That's the mechanism of attraction. What's the mechanism of repulsion? Well, we turn one of them around. We'll take axle, turn them around, and now the threads, right, are going to be clashing against each other and push each other away. Very simple mechanism. This is what Mother Nature has out there according to us, right? Very simple. And all we want you to do is to understand. Again, you believe whatever you want to believe, okay? But here it is. Okay, so here we have a series of atoms which are merged. And again, you have to look at these primarily as molecules, not as atoms. But we represent them with atoms just so that you can picture the mechanism. That's what we want you to see here, okay? If you have clockwise and clockwise, you know, they're moving all in the same direction like this, right? Then when one comes down, the other one's coming up because you have gazillions of these threads just moving around, just bumping into each other. There's a tiny friction there, and that's the aggregate of that is what pulls one magnet towards the other. The bottom, the opposite. They hit each other and they push each other away, whether it's, you know, downwards like this or upwards like that. Doesn't matter, okay? So those are two mechanisms. I hope you understand the mechanism. This is baby stuff. A 10-year-old can understand it. If you cannot understand what we're showing there, which is illustrated, which I'm explaining, well, then you should dedicate your life to something else. Okay, so it's very simple stuff. Okay, so here are the lines of force. This is how they go around, okay, a magnet. If you have the south side where the threads go in, the north side's where the threads come out. Okay, that's the so-called positive and negative. There's no such thing. There's just top and bottom in a magnet. Half of the magnet, the top side, you have going clockwise. The bottom one goes counterclockwise. Okay, that's what it is. That's how the threads. Now remember, you're looking at what's going around. You're looking at walls of threads from the side. Okay, so you're looking at a cross section of gazillions of threads. Sheet, you could say. You're looking at a piece of paper from the edge. That's essentially what we're showing here, okay? And so the arrows are showing what the whole wall of threads is moving around, how it's moving around. In other words, the walls of threads are going to be facing, from one end, it's going to be facing another magnet also pointing directly at it, okay? So here it is. We'll show you now a few more so that you can start getting an idea. Here we have four magnets. The top two ones are south to north. The two bottom ones are south to south. Okay, what is going to happen to the bottom ones? They're going to push each other away. Why? Because you can see what's happening to the walls of threads. They're coming against each other. The top ones are going in the same direction, and so when one comes down, the other one comes up. You got gazillions of these walls of threads. You can think of it like I call it the riverboat. You know, the paddles of a riverboat. They're moving around and they're encountering the paddles of another riverboat. Okay, and what are you going to do? Well, if they're going in the same direction, they're going to kind of attract each other. Okay, that's the idea. So just looking at the mechanism for now. Okay, and here you have it with a couple of magnets. You have one magnet on the right, another magnet on the left, and you can see what's happening to the walls. When one comes up, the other one comes down, and that's where the attraction occurs, the one on the top. The one on the bottom, they're just hitting each other away because they're north to north or south to south. Okay, so I hope you understand the mechanism. That's what we're proposing. We're doing it with real objects. We're doing it with threads and ropes. Thread is a rope. Thread is an object. A rope is an object. Okay. And people say, well, it's a concept, it's an abstraction. No. It's a real physical object that Mother Nature uses. It's just something we cannot see or touch. Not because of that is it abstract or it doesn't exist. It's there. Why? Because it's a real thread. It's a real thread, okay? It's not, it's not a concept. It's not a field. It's not an energy. It's not a time or mass or whatever. It's a real thread. We're talking about thread. You know, this is a rope, and this is what a thread looks like. Okay, for those of you who've never seen a thread, here, let me put it against my shirt. Okay, that's a thread. We're saying that's what it is. It's a real thread that Mother Nature uses to do these things because we're giving you a physical interpretation. Hopefully Mother Nature doesn't use black magic. She uses real physical objects. Threads are objects. Ropes are objects. Okay? We call it a rope because it has the shape of a rope, a DNA-like rope. That's what a rope looks like, DNA. And that's where probably the DNA got its idea from the rope. It's imitating the mediator of light. That's why everything, like collagen and so on, they're long strands. They're all long strands. And no one figured this out in 100. I mean, you don't have to believe it, but that no one ever proposed it. That's what's so strange. And again, they didn't propose it because they never defined the word object. They always thought an object is what you can see or touch. And no, that's not what an object is. An object is that which has shape. Not all objects can be seen. Air, for example. Not all objects can be touched. Like, the Klingons' chair over there at the other side of the universe, I can't touch it or see it for that matter. Does that mean it's not an object until I do? Until I go there and touch it, then it becomes an object? Then it exists? Okay, so here we have, again, axle and rod. They're going to sit on top of the magnet so you can see what's happening. When it's facing south to south, they push each other away. Now you have north to south. We're going to put the magnets closer together. You'll see what's happening to the ropes. They kind of latch onto each other. And if you switch them around like that, still nothing, they still attract. Only when you switch them around 180 degrees, one of them, right? Here goes, south to south, right? Only then do you have, repulsion. So it's a very simple mechanism. We have north-south attraction, right? You switch it up, down, and nothing changes because, you'll see it now in a second here. We'll switch them around, and you still have red on the opposite side of red from the edge. But now if you turn it around 180 degrees, now you have south against south, and look at the motion of the rope, it clashes. So that gives you an idea why magnets attract and repel. And again, we're looking at the mechanism. We're doing it with physical objects, threads, right? Not ropes, by the way. Again, one more time. I use the rope only because it's a skipping rope, right? But we're talking about threads, okay? The threads come out of the atoms and the ropes that interconnect them, and they swing around when the atoms twirl in situ, doing their electricity. Okay, the atoms do electricity, the threads do magnetism, okay, magnetic field. And here's a better picture of it probably, okay. You can see the magnets attracting each other, all the threads just swinging around, okay. When you have clockwise and clockwise, you have attraction. But when you have clockwise, and again, clockwise, when you turn it around sideways, it doesn't change. But now when you turn them 180 degrees, now you have push, okay. So I hope that's clear. Okay, one more time here, just in case. You got to look at the clockwise motion of the threads and the counterclockwise motion of the threads. That's what we're illustrating here. Clockwise against counterclockwise, they go against each other and push each other away. Okay, so that's the mechanism. We're using objects. It's rational. Okay, you can understand it. Hopefully, you can understand it. Do you believe in it? We don't care. We don't care if you believe. Science is not about belief. Science is about explanation and understanding. We're trying to make you understand using objects. We can illustrate what we're saying, something that no mathematician can do, whether in quantum mechanics or in general relativity or string theory. None of them can illustrate what they're talking about because they're illustrating concepts like field and energy and information and who knows what. Okay, so these are patterns that you'll see if you sprinkle iron filings between two current carrying wires. Okay, if you have current carrying wires, you pour or spread some iron filings, it'll give you these patterns here. Okay, you have the two on the clockwise side on the left, and what you'll see is that the threads are moving around the wires. Okay, at great speeds, and those are the lines of force that you will see around those wires. And in the case of the two wires that are running current in opposite directions, you have clockwise versus counterclockwise. They push each other away. Okay? And that's the patterns that they leave. You see these figure 8 on the left-hand side, but you don't see the figure 8 really on the right-hand side. You see them pushing each other away. Okay? So this is if you sprinkle, iron filings onto wires that are either carrying current in the same direction, attraction, or in opposite direction, repulsion. Okay, so here's just the wires. Okay, you'll see the pattern for attraction and the pattern of repulsion. Okay, and this is what's happening according to us, according to thread theory and the rope hypothesis, what's actually happening to these two real magnets. That's what they are. They're magnets because they attract or repulse just like ordinary magnets. Okay, and the patterns are on the bottom. Okay, and so you say, well, how do we know that there's all these threads swinging around causing this perturbation? Okay, and here you'll see it. Okay, here's a couple magnets. One magnet, I'm sorry. It's got a lot of iron filings, and you can see that this was done in slow motion. You can see that the iron filings are pulled up one at a time, slowly. See, if you do this in water real quickly, you won't see it. You got to kind of slow down your camera, and then you'll see how each iron filing is slowly, gradually being pulled up. That means something is swinging around and pulling all those iron filings upwards. Okay, something is swinging in that area that we cannot see or touch. Those are the threads. That's what we're saying that they are. Okay, and you say, well, where'd you get that idea? Well, here we have good old Maxwell and Michael Faraday, and they'll tell you in your face. And they worked with magnets quite a bit. And Faraday said, I cannot conceive curved lines of force without the conditions of what? Of a physical existence in that intermediate space. What did Maxwell say? Field, the space in the neighborhood of the electromagnetic bodies. In that space, what? There is matter in motion. Matter in motion. The threads that are moving around, we're saying, is the matter in motion, the exotic matter that good old Maxwell was talking about. Okay, so yeah, we do have some ideas of what's happening in that invisible world of magnetism. And just to rub it in here, we'll give you a couple more observations that people have had over the years. Okay, here's a coil. In other words, you're taking a wire and you're bending it one time around. And look at the threads, how they are moving. The ones on the bottom are moving counterclockwise, the ones on the top moving clockwise. Okay, and what do you see? You see force going through the center. Okay, that's what's happening there. Here it is again. So you have all these threads that are moving around the merged electron shells, which are spinning in situ, and the threads are moving properly in the direction that they should be. Okay, and what's happening? All these threads are pushing through the center of this half coil, you could say, just a bent wire, right? And you can see the force going through the center. Why it's going through the center? Because you have a physical entity that's pushing everything through the center. And that physical entities are the threads. Okay? And now here's the solenoid, a little built up now, you know, more than just one twirl of a wire, right? Here it is. And you see the same thing here. All the threads are moving bottom counterclockwise, top you're moving clockwise. Okay, they're pushing through the center from south to north. In other words, the so-called field, right, the magnetic field goes into the south pole and out the north pole. The force goes in there. Why? Because you can see it's threads that are pushing anything that you push in there. So if you put a charged particle or whatever in that region, well, the threads are the ones that are going to push that charged particle forward. Okay, and so that's a solenoid under the rope model. So yeah, magnetism is, you know, a bunch of threads moving around. That's what it is. That's what is between here. We can't see them. We can't touch them. The magnets recognize them, right? They do recognize each other, right? But we can't. We say, well, I can't see or touch anything. There's nothing there. Yeah, there is something there, but that something is untouchable, unseeable. It's invisible, intangible. Okay? Okay, I'm going to open up the floor for questions. Anyone who wants to ask a question, if I can't answer today, I'll take it to give you a rain check and try to answer it next week. Sometimes I get behind, like I did with this fellow, but what can I say? I got a lot of work. Okay, so go ahead. If you got any questions, ask them now. Remember, there's 10-second delay between transmission and you receiving it. Okay, so we have a little bit of patience. Why can't we touch the rows between two magnets? Because There's several questions. There's several answers to that. Okay, it's a long answer. The first one is no one in the last 10,000 years defined the word object. No one knows what a thing is, either in science, in physics, in philosophy, in the streets. No one has any idea what an object is. An object is not that which you can see or touch. So this is the first answer. So you're expecting to see and touch something which is unseeable, untouchable. That's the first answer. The second answer is that touch is an emergent property. You get touch when you have an atom. Why? Because here's the surface of an atom. Looks like a ball of yarn, right? Okay. So there's your ball of yarn. That's what atom looks like. What do you see? You see aggregation of gazillions of threads. Only then do you have touch that we can touch, humans, right? We have atoms here that are made like this. The surface is made like that. So now you have surface against surface. But until you have gazillions of threads, you don't have touch. Okay? And the same thing with magnets. Okay? Magnets, you have these walls that are swinging at great speeds. They're going through each other, but there's a very light friction, a mother's nature's level friction. Okay? So for us, we need atoms, and we don't have atoms here. We have just threads that are swinging at great speeds. So we can't touch those. We can touch atoms. I can touch the chair. Why? Because it's made out of atoms, and you have surface against surface. That's what you have. Okay. So those are the main two answers. And again, until you define the word object, you will not make any progress in physics, because physics cannot be done without objects. These people don't do physics with objects. They do it with concepts, and that's what's thrown generations of people off the trail. That's what it is. So those are the primary ones. Essentially a rope and a thread are untouchable. They can go right through each other because they don't understand touch at that level. If you want to have touch in Mother Nature's world, you need aggregation. And there's also an issue of speed. I'm not going to get into that, but there's other factors, okay? But those are the two primary ones. Okay, let's see what else we have. No, the question is, are the threads like mini ropes? No, let's make sure we understand. Rope, two threads. Thread, single thread. Okay, so a thread is just one, it's just one of these. You can see it there against my shirt. Thread is just one thread. The other one is, like that. Okay, so rope is different than thread. Okay, let's make sure we understand that. Okay, and again, the purpose here is to understand, not to convince or persuade or convert. Okay, fellow says, your jump rope analogy doesn't work, okay? The rope should tangle up. Yeah, again, talking about see-touch. As long as you talk about tangling, you haven't understood squat, okay? Yeah, this is what throws everybody off, the touch issue. It's a touchy issue. But see, people like this gentleman there and the other ones, they never define the word touch. They don't know what they're talking about when they use the word touch. And again, it's extremely important to define these words in physics. You need to know what touch means for the purposes of physics. And no one's ever defined the word touch. Everybody said, well, I know what touch is. I touch the table. So you need to define the word touch, and people have never defined that word. So I had to be the first person to define the word touch because of this problem, because people say, oh, what about touch of ropes and threads? Yeah, this is the problem. The problem is touch. Yeah, the electric and magnetic thread make the rope. Now, we use the word electric and magnetic only to keep with convention. There's no difference in colors. There's no difference in the thread itself. It's a single thread in the entire universe. But we call one the magnetic thread, the other one the electric thread. The magnetic thread arbitrarily is the one that we say is the one that winds around and forms the electron shell that encapsulates the proton star, which is made of electric threads. Arbitrarily, again, we could have called them X and Y. We just want to keep with convention. We think it's better to talk, if they talked about electric and magnetic fields, we're going to talk about electric and magnetic threads only to keep with convention. Other than that, it's just words. Well, the kind of thing, yeah, they are things. Okay, a thread is a thing. This is a thing. Thread is a thing. Okay, a rope is a thing. This is a thing. Okay, and what I'm saying is this is a representation, just an architectural, a structural representation of what we think Mother Nature runs her universe with. She runs it with this, according to our theory, right? She runs it with a physical object, not with concepts invented by man like field and energy. It runs it with a physical object. You need objects to do physics. And one thing that you will never have an explanation to from the establishment, from the mathematical establishment, is the force of pull, the force of attraction. Look it up anywhere you want. See if you find attraction anywhere in mathematics, in the religion of mathematics, or even the dissidents. Go to the electric universe, go to the ethers, go to the flat earthers. How do they produce pull? The only way you're going to produce pull is with an elongated object that extends from one object to the other. That's the only way. You want to pull on a horse, you can't do it with stones. You can't do it with rocks. You need to put a rope around its neck and then pull on it. Then you can understand pull. If you're going to throw rocks, you say, well, how did you pull on the donkey? Well, I did it by throwing rocks at it. Maybe you can pull on a lion like that. Lion will come towards you, but not a donkey.